Happy Friday! Welcome to TVE Happy Math Hour, our weekly interactive math reviews for Math 1314 and Math 1324, presented by Yvette Chuca, Ruben Carizales, and Alberti Sassi. Our session will be starting soon. This session will be recorded so that you may come back to it later if you need, and so others who may have missed out on today's events will be able to come and watch it. This session will provide Tejano passport points, and the code will be posted on the chat towards the end of the session. Thank you. So now, at this time, please mute your mics for the best sound experience. Otherwise, the feedback could interfere with information we will be sharing. We'll be sending the 1324 room link on the chat so that you may connect to your session if you're here for Math 1324. Without further ado, I'll pass it on to our presenter so that we may begin.
Hello everyone, happy Friday. So today for Math 1314, we're going to continue looking at exponential functions. If you are here for 1324, they just posted the link for you. And so we will go ahead and start. If you have any questions, please just let me know as I go through the presentation. If you would like to download this presentation, on the right side of the screen, you should see a box with an arrow pointing down. If you click on that, it will allow you to download the presentation. Okay, so last Friday, we looked at exponential functions and logarithmic functions, and we also looked at some properties. And so for this week, we're going to be looking at solving these equations and using some of the properties to help us solve these type of equations. So in this example, we have log 5 of 125 is equal to x. So there are different ways to solve these functions. One of those ways is going to be to convert this equation from logarithmic to exponential. The other way you can do this is you can ask yourself, what power does 5 have to be to give you 125? And so if you can look at it this way, then that's one way to solve it. Of course, we're not always going to have a perfect number like we do here. And so if that happens, then we would have to change it to exponential function. Okay, so here I'm going to go ahead and change it to exponential function. And so my base is 5. So I'm going to have my base is 5. And then I always say the log is equal to the exponent. So in this example, this log is equal to x. So x is going to be your exponent. And then here we can try to change this to one-to-one property. The 125 can be written as 5 cubed. And so since the bases are the same, I can set the exponents equal to each other. And so my solution here is x is equal to 3. Okay, let's try another one. So here I have a base of 2. So if you try to ask yourself what power does 2 have to be to give me 25, then we're never going to get to an answer, right? Because that's not going to be, we can't find that number that will give us 25. We could find a decimal for it, but that might take longer. And so the best thing to do here is going to be to change it to exponential form. So our base is 2. This log is equal to x, so x is going to be my exponent. And then this is equal to 25. Okay, so if I try to use the one-to-one property here, then we can see that that's not going to work out either, because 25, I cannot rewrite it so that it has a base of 2. So we're going to need to do other things to find a solution. So a calculator is going to be useful here. And so let me talk about calculators really quick for a second. So the calculator on the left side is a graphing calculator. This would help you do logs. The only problem with this left side calculator is if you have a log with a base that is not 10 or a base that's not the natural log, then the calculator, you're not going to be able to use it. You'll have to use something else, which I'm also going to show you here today. Now the calculator on the right is a Casio scientific calculator. And so this scientific calculator, if you notice, it does have space for you to put the base and then the numbers so that you can find an answer. So these Casio calculators are scientific, so They're less than $20, but I'm not saying to go buy a calculator. If you have a graphing calculator, that's still gonna be able to, we're still gonna be able to use that to find our solution. Okay. So in order to solve problems that look like this, if you have a graphing calculator or even the Casio calculator, we can use something called change of base. So all the calculators work in base 10 or in base E. So the idea is to take a logarithmic equation and change it to a base that we can use in that calculator. And so if we change this to a base 10, then we're going to have log x divided by log a. So your base is always going to be in the denominator. Or you can use the natural log instead of the log. Okay. So for example, here we want to evaluate this logarithmic using the change of base. And so notice we have a base 3. So I cannot use that on my calculator. So instead, I'm going to change it to base 10. So now I would have log 11 divided by log 3. And my calculator, I can enter it as log 11 divided by log 3. And then my approximate answer would be 2.183. Okay, and then for the next one, the base is pi, so I cannot put it like this into the calculator. So I need to convert it using the change of base formula. And so I'm going to have log of 0.5 divided by log of pi. And if I enter it in the calculator, then I get approximate negative 0.606. Okay, so the change of base formula is going to be able to help us to solve these type of equations. So last time we looked at some of these properties. So today we're going to look at a few others. We're going to focus on the top 3. So it says use the properties of logarithms to write the logarithm in terms of log 5(2) and log 5(3). And so the product property tells us that if we're multiplying two expressions here, we can separate it into different logs using addition. If we are dividing, we can separate it using subtraction. And if we have an exponent here, we can bring that power, that exponent to the front, and then we have our log. Okay, so here it says that we want to take log 5 of 6 and rewrite it in terms of log 5(2) and log 5(3). So the first thing we can do is we can use the product rule. And so the number 6 we can write as 2 times 3. Since I'm multiplying, I can separate it with addition. And so I would end up with log 5 of 2 plus log 5 of 3. Again, here, find the exact value of the logarithmic expression without using a calculator. So one of the things in this chapter is anytime you see a square root, or in this case, a cube root, you want to rewrite it as a power. Okay, so it's going to be a exponent that is a fraction. So this cube root of 3, I can write it as power of 1/3. If I had the square root, then there would be, the power would be a half. If I had a fifth root, it would be a fifth, and so on. So this is going to be equivalent to log 4 of 4 raised to the 1/3 power. And now I can use the power rule, and I can take that exponent 1/3 to the front. So I'm going to have 1/3 log 4 of 4. And now notice that I have a base of 4 and I have a 4 here. These are the same. So I'm going to be able to use one of these properties. And notice here when they're the same, it's going to be equal to 1. So if I replace that, log 4 of 4 is just 1 times 1/3 is going to be 1/3. Okay, so my answer for this is going to be 1/3. Okay, we have a few more here. So same idea, the first one. I have a fourth root, so I'm going to change it to an exponent. So I'm going to have e cubed raised to the 1/4. And then I can apply the power rule to get rid of that exponent. So, or I guess we can simplify first. So e to the third raised to the 1/4, we're going to end up with e to the 3/4. Now I can use the power rule, and take that exponent to the front. So we have 3/4. And then I have natural log of e. So natural log of e is the same as saying log with the base e of e. So notice that the bases are the same. So again, we can use the same property that we'd used earlier. If the bases are the same, then that's going to be 1, and then we get 3/4. Now, sometimes people like to say that the natural log of e, they might just cross it out. But when you're crossing it out, just remember that it's actually a 1. Okay. Let's try the next one here. So we have natural log of e to the 4th plus natural log of e to the 8th. So we're going to apply the power rule, which tells me that I can take my exponents to the front. So I have my 4 here, and then I have my 8. And so now I can use logarithmic properties. So natural log of e is 1, natural log of e is 1, 4 times 1 is 4, and 8 times 1 is 8. So I get 12. Okay, so now here we have use the properties of logarithms to expand as expression of sum or difference. And so whenever you see the word expand, what they want us to do is take this one logarithmic expression and write it in multiple logs. Okay, and so we're going to apply the properties here. So if you notice here, I'm multiplying z times z minus 1 to the 4th. Since we're multiplying, we can apply the product rule. Remember, the product rule says that we can separate these two with addition. So I'm going to have natural log of z plus natural log of z minus 1 to the 4th power. Next, I want to see, can I simplify any further? Well, I can apply the power rule to this exponent of 4. So that's going to allow me to take the 4 to the front. And so now I have natural log of z plus 4 times natural log of z minus 1. And so if you notice, we came from one natural log to multiple natural logs. You might be asking yourself, well, why do we need to do that? So in a little bit, when we're trying to solve equations, it'll be helpful so that we can use that to be able to solve for x or whatever variable we have. So again here, notice we're dividing. We're dividing the square root of x squared minus 9 divided by 4. So for division, we use the quotient rule. And the quotient rule says we can separate with subtraction. So we have log 5 of the square root of x squared minus 9 minus log 5 of 4. Now we want to see, can we simplify any further? I see a square root. So I know that the square root, I can write it as a power. And so that's going to be log 5 of x squared minus 9 raised to the half power minus log 5 of 4. Well, now what can I do with this exponent of a half? We can apply the power rule and bring that half to the front. So I have 1/2 log 5 x squared minus 9 minus log 5 to the 4th. And so if we observe this, we see x squared minus 9. I can go ahead and factor that further. X squared minus 9 can be factored as x minus 3 times x plus 3. And now these are being multiplied together. So I can apply the product rule, which means that I can separate with addition. But don't forget that you have a half in the front, so the half would need to be applied to these two when we separate it. So we're going to have 1/2 log 5 of x minus 3 plus 1/2 of log 5 of x plus 3. So again, the plus comes from us having this multiplication that can be separated using the product rule. And so my final answer for this is going to be this last sentence here. Okay, now let's see a few more examples. So here we're dividing. So I can apply the quotient rule and separate it with subtraction. So log 8 of x cubed minus log 8 of y cubed times z to the 4th. And so if I evaluate this, I have an exponent here. So I know I'm going to use the power rule, and I have some exponents here, but I'm also multiplying y cubed and z to the 4th. So I can separate the y cubed and the z to the 4th. So I can apply the product rule. So I'm going to end up with log 8 of y cubed plus log 8 of z to the fourth. Notice I put parentheses here because the minus sign in front of this log is going to have to be applied to everything that comes after that subtraction sign. So if we simplify further, I'm going to distribute that negative. So I end up with negative log 8 y cubed, and negative times this one is negative log 8 z to the fourth. And now I can apply the power rule. So the power rule will allow me to take the exponent 3 to the front, and then this 3 to the front, and the 4 to the front. And there's nothing else I can do, so that's going to be my final answer. Now for letter B, we have the 10th root of all of this stuff, right? So first, let's rewrite that 10th root as a fraction, as an exponent. So we end up with x to the 7th times x to the 5th plus 7 raised to the power of 1/10. Okay, so now we can apply the power rule, take that 1/10 to the front, and now I have 10 to the front, and now I have this expression left. So here we're multiplying, so we can apply the product rule and separate it with addition. So I'm going to have x to the 7th plus natural log of x to the 5th plus 7. I need to distribute that 1/10 into each of those natural logs. So I end up with 1/10 natural log of x to the 7th plus 1/10 natural log of x to the 5th plus 7. And then I can go ahead and apply the product rule, the power rule. So this 7 I can take to the front. So I end up with 7/10 natural log of x plus 1/10 natural log of x to the 5th plus 7. So you might be asking yourself, why didn't I take this 5 to the front? And the reason is because it's joined together with this plus 7. So we can separate these from each other. So all of those were expanding logarithms. Now we're going to condense. So condense means you have multiple logarithms and we want to rewrite them so that we only have one logarithm left. Okay, so what do we want to do here is, if we notice we have this log being subtracted from this log. Before you do anything though, you want to make sure that the numbers in front of the logs are ones. If they are not a 1, then we want to go ahead and apply the power rule. And this 9, for example, came from being an exponent, so we're going to put it right back as an exponent. Okay, so always make sure that the numbers in front of logs are taken back as exponents. So the 9, I can break it in exponent. So now I have log base 6 of x to the 9th. Now I can apply the quotient rule since I have subtraction. So I'm going to end up with log 6 of 3x divided by x to the 9th. I can simplify. So one of the x on the numerator, I can cancel with 1 on the denominator. So I end up with 3 divided by x to the 8th. Okay, let's try these here. So in this example, I have 3 logarithms. I don't have any parentheses or anything. But the first thing is to deal with these numbers in front. So let's rewrite those as exponents. So we're going to end up with y to the 6th and z to the 7th. If you don't have any parentheses or anything, you want to start from left to right. So we're going to combine the first one, log x minus log y to the 6th. Since they're being subtracted, I'm going to go ahead and apply the quotient rule. So now I end up with log x divided by y to the 6th. And now I'm adding z to the 7th. So if I have addition, I can use the product rule. And so I end up with log of x divided by y to the 6th times z to the 7th. So if I simplify, then I end up with x times z to the 7th divided by y to the 6th. Okay, so this is another example. The important thing here is if you don't have parentheses, work from left to right. If you look at letter B, I do have some brackets here, which serve as parentheses. Okay. So what this means is that they want us to work out whatever's in this brackets first. So if I have natural log of x plus 1 plus natural log of x minus 1, then addition means that I'm going to use the product rule. And so from addition, it becomes multiplication. So I have natural log of x plus 1 times x minus 1. Now I have natural log of x minus this here. So if I have subtraction, then I'm going to use the quotient rule. Okay, I guess let me just multiply it out. So x times x is x squared, x times negative 1 is negative x, 1 times x is x, and 1 times negative 1 is negative 1. Combine your like terms, and so we get x squared minus 1. So now let's apply the quotient rule. So I can write it as x divided by x squared minus 1, and that would be our answer. Okay, so now that we've seen all these properties, then we're going to start solving for x. So in this examples here, I have 2 to the x is equal to 4. So this is an exponential function. Always, in my opinion, I always tell my students, try to apply the one-to-one property first. If you can apply the one-to-one property, then that's going to make things a little bit easier. So for example, I have a base 2 and a base 4. Just by looking at it, we can figure out what x is, but I'm going to go ahead and work it out. So 4, can we write 4 so that it has a base 2? And so the answer to that is yes, right? We can write it as 2 squared. Since the bases are the same, then I can set the exponents equal to each other by using the one-to-one property. And so my answer is x is equal to 2. Now we look at letter B. We have natural log of x minus natural log of 13 is equal to 0. So again, our goal is, can we somehow manipulate this so that we can use the one-to-one property? These both have the same base, right? The base is e. And so what I could do is I'm going to add natural log of 13 on both sides. And so now I have the same base on the left side and the same base on the right side. And so with the one-to-one property, I can set x is equal to 13. Now for logarithms, you want to check your final answer. If I plug in 13 for x here, is that a positive number? Yes. So then that means that it is a solution. And I'll talk about that further in the next slides. Now here we have e to the x is equal to 13. 13, there's no way for me to change this so that it has the same base. So one of the ways to solve this type of problem is if you have an exponential function, then what we could do is we can multiply both sides by natural log. And so I'm going to have my natural log. And so I'm going to have natural log of e to the x is equal to natural log of 13. Now the natural log and the e, we can apply the logarithm properties. So I can take the x to the front, so as a power rule, and then the natural log and the e become 1. Okay, so let me actually write it out really quick. Okay, so for this right here, if I use the power rule, I get natural log of e, and this right here is equal to 1. So we get x. So that's how we end up with just the x right here. So x is equal to natural log of 13, and natural log can be put into your calculator. So in your calculator, we would enter natural log of 13, and we would end up with 2.565. Okay, so let's try this one. So here we have exponential function. Notice that the base is the same, so you have e and you have e. So we can set the exponents equal to each other, and then we can solve for x. Notice that x squared tells us this is quadratic. So if it's quadratic, everything has to be on the same side. So I'm going to bring this x to the right side, and I get 0 is equal to x squared minus x minus 6. At this point, you can try to factor, or you can use a quadratic formula. Okay, so this does factor. So we get x minus 3 times x plus 2. Set each of the factors equal to 0. So we end up with x minus 3 equal to 0, and x plus 2 is equal to 0. If we solve for x, we get x is equal to 3, and x is equal to negative 2. We don't need to check our answers because this is exponential. Now here are some more exponential functions. If we want to solve this, then we want to isolate whatever is the exponential part. So 3 to the x, we want to leave that by itself. So I'm going to divide by 5 on both sides, and I'm going to get 3 to the x is equal to 4. At this point, I cannot change 4 to have a base of 3, and I cannot change 3 to have a base of 4. So at this point, I need to find other ways to solve for x. So one of the ways is going to be to multiply by natural log on both sides. So I have natural log of 3x is equal to natural log of 4. I can apply the power rule. So the power rule will allow me to take x to the front of the natural log. And so now I'm able to solve for x. So in order to solve for x here, I'm going to divide by natural log of 3. And so I end up with natural log of 4 divided by natural log of 3. So this is an exact answer. If you want an approximation, or if in this case it says to round to 3 decimal places, then you can enter it in your calculator, and we would end up with 1.262. Now on the right side, e to the x is your exponential part, so we need to leave that by itself. So that means that this minus 9, I'm going to have to bring to the right side. So I'm going to add 9 on both sides, and I get e to the x is equal to, so here if I add 9, it's not going to be 27, right? So let me go ahead and correct that. Or actually, probably to make it easier, the correction, let me change that to a positive, since the rest of the slides will be worked out with the negative, with that. So if I subtract 9 on both sides, then I get 27. So in order to solve this, then I'm going to multiply by natural log on both sides. So I get natural log of e to the x is equal to natural log of 27. Use the power rule so I can take the x to the front. And I get x is equal to natural log of 27. If we get a decimal, then we end up with 3.807. Let me go back really quick. So I think I probably combined a different problem in here because I'm not sure how I went to 45. So this would have to be natural log of, so probably I had the, okay, so I know what happened. So originally I subtracted from the 36, and then I probably realized that I was supposed to add it the whole time. And so this is actually the correct answer here, right? So if you add 9, you get the 45. Take the natural log of 45, and then we end up with 3.807. All right. Now we're going to solve some logarithmic equations. So in order to solve for x here, it's really hard to do that because the x is kind of trapped with that natural log. Okay, so if we have a natural log like this, then the best thing to do is going to be to change it to exponential form. So natural log I can write as log e of x is equal to negative 4. If I change this to exponential form, my base is e. The log is equal to the exponent, in this case negative 4. And so then I can just put that in the calculator, e to the negative 4, and I get 0.018. You want to check your solution. Since we're working with logarithms, whatever x is has to be positive. So if I put 0.018 in here into this x, then I get natural log of a positive number, which is going to be okay. So that is going to be a solution. Okay, what about this one? We have 2.8 is equal to natural log of 3 times x. So we're going to change it to exponential form. So natural log can be written as log e of 3 to the x. So my base is e. The log is equal to 2.8. So that means that the log is your exponent is going to be 2.8 is equal to 3 to the x. Now I can solve for x, so I can divide by 3 on both sides. Now I can solve for x, so I can divide by 3 on both sides. And I end up with this. If I put this in the calculator, then I end up with 5.482. Okay, on this next one, we need to isolate that logarithm. We need that logarithm to be by itself. So I'm going to go ahead and subtract 5 on both sides. And we end up with 6. And then I'm going to divide by that negative 5. And so we end up with natural log of x is equal to negative 6/5. I'm going to go ahead and convert to exponential form. So again, natural log of x is the same as log e to the x. The log is always equal to the exponent. So that means that negative 6/5 is your exponent. And now I can plug that into the calculator. So we get 0.301. So now when we have multiple logs, let's see what we can do with these. So on the left side, I have 2 logs. In order for me to do anything, in order for me to convert to exponential form, I should only have 1 log. And so one of the things I can do is combine these 2 logs together. Since they're being subtracted, I can apply the quotient rule, and I can rewrite it as natural log of x divided by x plus 6. Now I can convert it to exponential form. So my base is e. The log is equal to 7, so that makes 7 the exponent. And now I'm ready to solve for x. So in order to solve for x, I'm going to multiply by x plus 6 on both sides. So I get e to the 7th times x plus 6 is equal to x. Now I'm going to distribute that e to the 7th. So I get e to the 7th x plus e to the 7th 6 is equal to x. So I want all the x's to be on one side so that we can solve for it. So I'm going to subtract x to this side, and I'm going to subtract e to the 7 times 6 to the right side. Now notice that I have this term with an x and this term with an x, so I can factor out an x. So I'm going to have x is equal to e to the 7th minus 1. And then I'm going to divide by e to the 7th minus 1. And so I end up with negative e to the 7th times 6 divided by e to the 7th minus 1. When you enter this in your calculator, be careful with your parentheses, okay? Or try to do it one at a time, okay? So our approximation would be negative 6.005. So what I did on my calculator is I entered negative e to the 7th times 6 first. That was my answer here. And then I just pressed the division symbol. And then I put e to the 7th minus 1. I went ahead and put parentheses so that I can be sure that it's dividing by the entire thing and not by e to the 7th. Now that we have these possible solution, we want to make sure that it is a solution. Okay, so my answer was negative 6.005. If I come to my original equation, I have natural log of x. So I'm going to have natural log of negative 6.005 minus natural log of whatever this is here. But if you notice here, the natural log of a negative number, if you do that, it's going to give you an error because the domain for these natural logs is from 0 to infinity, with 0 not being included. So therefore, since this is negative, then we say that there's no solution. For letter B, I can combine the 2 logarithms on the right side using the quotient rule. So I'm going to have x minus 6 divided by x plus 6. Notice they have the same logs. Therefore, I can apply the 1-to-1 property. And I can say that x plus 9 is equal to x minus 6 times x plus 6. So in order to solve for x, I'm going to multiply by x plus 6 on both sides. So I get x plus 9 times x plus 6 is equal to x minus 6. So if we simplify, we get x squared. X times x is x squared. X times 6 is 6x. 9 times x is 9x. And 9 times 6 is 54 is equal to x minus 6. Gather your like terms. So we have x squared plus 6x plus 9x is 15x plus 54. Notice it's quadratic, so I need to make sure everything is on the same side. So I'm going to subtract x, and I'm going to add 6. So we simplify. We get x squared plus 14x plus 60. At this point, it's quadratic, so you can either factor or use a quadratic formula. I went ahead and used the quadratic formula. So I have 14 is my b. So I have negative 14 plus or minus 14 squared minus 4 times 1 times 60 divided by 2 times 1. So if I simplify, then I end up with a negative in the square root. That means that there will be no solution. Okay, let's try one more. So here again, I'm subtracting. So I can combine with division using the quotient rule. So I end up with x divided by x minus 8 is equal to half. I can change to exponential. So I end up with 9 raised to the half power is equal to x divided by x minus 8. And then remember that whenever you see an exponent that's a fraction, that means that it's a root. So here I have the square root of 9 is equal to x divided by x minus 8. So the square root of 9 is plus or minus 3. And then I need to solve for x. So I get two possible answers. I get 3 times x minus 8 equals x, and I get negative 3 times x minus 8 is equal to x. So if I distribute that 3, I get 3x minus 24 is equal to x. If I subtract the x, I get 2x. And if I bring 24 to the right, I get positive 24. So x is equal to 12. On the negative one, we get negative 3x plus 24 is equal to x. Subtract the x, so I get negative 4x. I subtract 24, so we get negative 24. Divide by x, so we get 6. So these are possible answers. We need to check them. So if we check with the 12, if I plug in 12 for x, then I'm going to have 12. 12 minus 8 is 4, so the 4 is positive. The 12 is positive, so that's good. So that means that x equals 12 is a solution. If I plug in the 6, I get a 6. 6 minus 8 will give me negative 2. Since I have a negative here, then that means that x equals 6 is not a solution. So your only solution is x equals 12. Okay, so some of you will be taking exam 3 this week, so good luck to you on that. Since we have some time still, I'm going to go ahead and for this week, if we're following the 10-week calendar, we can look at chapter 7.1. So I'm just going to cover a little bit about 7.1. Let me just get the file uploaded. In the meantime, if you have any questions, feel free to ask. Let's see, where is it? Okay, so it's uploading right now. So for chapter 7, um, we're going to start looking at linear equations. And so next week, I'm going to go ahead and continue with this presentation. For today, I'm just going to do a part of it. So a linear system is made up of more than one linear equation. And a solution to that system is basically an order pair that will satisfy both or more equations. Solution set is all the order pairs that satisfy both equations. Sometimes we could have more than one solution. So a system with only linear equations is called a linear system, but there's some that have nonlinear equations. There's different ways to solve these systems. You can use substitution, elimination, or graphing. So the solution of these equations is where the graph intersects each other. So for example, if I have this graph here, I have a line, two lines, and they intersect at the point 2, 0. And so since they intersect at 2, 0, that means that that is a solution to that system. Okay. And if we look at this example, this is a nonlinear system because there's a quadratic equation here. And so if you notice here, it says find the solutions. The solutions are where the graph intersects. So in this example, there's two solutions, 2 and 1, and 0 and -1. Now the third one is a nonlinear system, and the solutions, there's going to be no solutions because the graph does not intersect. So we would just write no solution. So if we want to know whether this pair is a solution to the system, then what we're asking is this point 0, -4 the point where the two lines intersect? Okay, that's what we're asking. And so in order to do that, one, you could graph these, but graphing is usually not the best option if you're doing it on paper. So one way to solve for this is we just plug in your x and y into the equation. So I'm going to have 2 times 0 minus -4 is equal to 4. And if I simplify, then I get a true statement, 4 is equal to 4. However, that has to happen with the second equation. So you also want to check the second equation. So 8 times 0, and then we have -4. So we end up with -4 is equal to -9. This is not a true statement. So since it fails for this second equation, then we say that 0, -4 is not a solution to the system. If we look at letter B, if I plug in -1/2 for x and -5 for y, and I simplify, I get 4 is equal to 4, which is a true statement. If I plug it into the second equation, 8 times -1/2 plus -5 is equal to -9, then that also gives me a true statement, and therefore that point, -1/2, -5, is a solution to that system because it satisfies both equations. So to solve the system using substitution and elimination, so I'm going to do substitution first. So what you want to do for substitution is pick one of the two equations and solve for a variable. So here I'm going to solve for x. So x is equal to 4 minus y. Then what you want to do next is you want to take that information and plug it into the equation that you haven't used. So I have not used x minus y equals 2. So wherever I see an x, I'm going to go ahead and put 4 minus y, and then I'm going to simplify. Okay, so 4 minus y is the same as 4 minus 2y is equal to 2. And so I'm going to subtract the 4, and I end up with -2y is equal to 2 minus 4. 2 minus 4 is -2, so y is equal to 1. So right now, that is our y coordinate. Now we need to find the x coordinate, so we do something called back substitution. So I can take this answer and plug it into any of the two equations. I'm going to choose the first equation. So I end up with x plus 1 is equal to 4. Subtract the 1 and I get x equals 3. So my solution is 3 and 1. Now the elimination method is just another way to solve this. And so depending on how the system is already given to us, then that's how I determine which method I'm going to use. But you can stick to either method. They should both give you the same answer. So here we pick a variable that we want to eliminate. So I'm going to get rid of the y's. And so notice here that the y is positive and this y is negative. And that's what we want. We want one to be positive and we want the other to be negative. And we need them to have the same coefficient. So there's a 1 in front of this y and there's a negative 1 in front of this y. If we have that already, then all we have to do is add the equations. So x plus x is 2x. Y minus y is 0, so they cancel. And 4 plus 2 is 6. If I divide by 2, I get x is equal to 3. And now I back substitute. So I get x plus y equals 4. So my x is 3 plus y is equal to 4. So I end up with y is equal to 1, which is the same answer as before. So here's my solution, and this is my solution. Using two methods, they both gave me the same answer. Okay, I think we have time for one more. So solve the system using any method. So notice here that in this method, one of the equations I'm already solved for y. So the method that comes to mind first is a substitution method. So I know that y is equal to 2x plus 3. So wherever I see a y in the second equation, I'm going to replace it with 2x plus 3. So if I do that, then I get x. Let me go ahead and do it again. So I get x plus 2 instead of y. I'm going to put in 2x plus 3. And now I'm going to simplify. So 2 times 2x is 4x. 2 times 3 is 6. And x plus 4x is 5x. Subtract the 6, so we get negative 10. Divide by 5, so we get x equals negative 2. Now we can back substitute, so we can take x equals negative 2 and plug it into any of the equations. I'm going to plug it into the first one. So I end up with 2 times negative 2 plus 3 is equal to y. So 2 times negative 2 is negative 4 plus 3 is negative 1. So my solution, you always write it as an ordered pair, is negative 2 and negative 1. If you had used the addition method, then you would still end up with the same answer. Okay, so here's another one. I already solved for y, so I can just substitute it. Okay, so I'm going to go ahead and substitute that in there. So y here is 3x minus 2 times y. So for y, I'm going to plug in 2x minus 3. And so I end up with 3x minus 4x plus 6 equals 7. 3x minus 4x is negative x. And I'm going to subtract 6, so I get 7 minus 6 is 1. Divide by negative, I get x equals negative 1. Back substitute it, and I end up with y equals 2 times negative 1 minus 3 is negative 5. So again, when you back substitute, you don't have to use this equation. You could have used the first equation, and you'll still get the same answer. So your solution set is negative 1, negative 5. Okay, so next time when we meet on Friday next week, then what we're going to do is we're going to continue with solving these equations, and we're going to look at these systems of nonlinear systems, and then we'll go on from there. So if you have any questions, feel free to stay here and ask those questions, and I'm going to go ahead and pass it over.
Okay, thank you very much, Ms. Chuka, for this wonderful presentation. And thank you so much for all the attendings for sticking around. If you have any questions, just go ahead and raise your hand and we'll address them in the chat. For those of you who joined us late, you can catch the whole recording on the YouTube channel, or you can download it, download the presentation just by clicking on the top square with the arrow pointing down. Next week, which is going to be July 26th, we have the Happy Math Hour at 11 a.m., Math 1314 Linear and Nonlinear Systems, and Math 1324 Exam 3 Review. For 1 p.m., we have the Writing Center with Vanessa Zuniga. So if you have any questions, raise your hand and ask them. If not, thank you very much for joining us, and check us out next week.